Hey guys, sorry for the jump cut that's going to happen in this video. I kind of got distracted by something. So let's finish up this problem. Part D is going to be so what they're asking us is basically determine the frequency at which VO equals 1/2 Vn. So if we look at that, VO equals 1/2 Vn. That's going to be with some very slight rearranging. 1/2 equals VO over Vn, which is our voltage gain. So we take the voltage gain equation and we're going to rearrange it to solve for X, and then we'll use that to solve for frequency. It's just the opposite of what we did in the previous problem. So first we're going to take that equation, AV over 1 over square root of X over R, and that's squared, plus 1. And we're going to rearrange it. So first thing to do, take the reciprocal of both sides. That means flipping them to the top or the bottom, depending on what they are, and then squaring them. So you're going to get 1 over A. I'm just going to write A for convenience, squared. And then we have no longer square rooted. We've got X over R squared plus 1. So like I said, we just flip them to the top and the bottom respectively, which you're allowed to do. And then we took the square of both sides. So the square root got removed on the right side, and it now exists on the left side. Next, we subtract the 1, and we take the square root of both sides, which is going to give us X over R equals 1 over A squared minus 1, all square rooted. And lastly, we just multiply both sides by R to get our final equation of XC equals R times the square root of 1 over A squared minus 1. And then we'll plug everything in. So this R value is 100K. And then this value right here is 1 over 0.5 squared. Remember, 0.5 was that gain that we had earlier right here, minus 1. And that's all square rooted. And we're going to get from that 100K times the square root of 0.5 to the negative 2 power minus 1. That's going to give us 173.21. And that is kiloohms. Remember, kiloohms. So finally, we just take the XC equation. So that's 2 pi FC, and we rearrange it to solve for frequency, because that's what we're looking for, frequency. So frequency is 1 over 2 pi XC times C, which is 1 over 2 times pi times 173.21 killi. And then in this problem, C was 20 picofarads. Remember, pico is 10 to the negative 12. So that's going to give us an answer of roughly 45.95 kilohertz. And that is our answer. So that's just demonstrating our ability to figure out, like, okay, so if I want the load at this voltage, what frequency should I operate the source at to get that outcome? And that's going to be it for problem 19. Thanks for watching.